Good evening, students. We will once again go back to the graphical analysis and solve a few questions on uh, motion in one dimension, okay, with regards to how the graph of the motions look like. Okay, so we have a question. You can see I have drawn 4 different graphs. All these graphs are showing a particular kind of a motion. All these 4 graphs are drawn between velocity and time. As you can see, velocity versus time here, and velocity versus time here. The only thing different that you see is the way these motions are depicted. Okay, so these are all different kinds of motion taking place, and we have a question based on which we have to select an appropriate option out of these 4. So the question here is that a body is thrown vertically upwards, okay, with some velocity. So what will be the nature of the v versus t graph that will be drawn for the motion of that body? So I'll repeat the question again. There is a ball or a body, you can say, which is being thrown vertically upwards. Why does it need to be thrown? Because we all know that everything is being attracted towards the earth with the help of that gravitational pull of the earth which is there. Okay, so the earth is trying to pull everything down towards itself. Therefore we have to make that attempt of throwing something with some velocity so that it goes up and then it will come back. Okay, so that is how the situation is. That is what the situation is. We have to show right from the point of throwing, we have to show how this motion of the body going up and then coming down will be represented in terms of any one of these 4 graphs. Okay, so before going ahead directly to the right answer, we will analyze all these 4 graphs based on the way we have been studying the graphs of different motions, and then we will come to a conclusion. But before starting the discussion, let me again brief you about time and velocity. Now, time is a scalar quantity, but velocity is a vector quantity. Please note, children, that velocity being a vector quantity would mean that it has plus and minus signs, okay, which denote that the body is moving in a particular direction with some speed, and then if that sign of that velocity becomes minus, or it changes from plus to minus, then that would mean that the body has taken a reverse turn. So earlier, let's say for example, earlier if the body was moving like this, it was having a positive velocity if it was moving like this. So if it has a negative velocity, then that means it is going right in the opposite direction to the earlier direction. Okay, so that is something that we will have to keep in mind in order to answer this question. Okay, so let us analyze the first graph that we have here. So what is it that we need to know? That the motion in this first graph, it is starting from here, and you can see that this is a straight line which is coming down. So any line which is coming down will mean that the body started with some velocity, okay, and its velocity is now reducing. Okay, so constantly with increasing time, the velocity of that body is decreasing. Now let us think about the situation. The situation was that the ball had been thrown up. So when somebody throws the ball has been given some velocity. So that is this velocity. Okay, now when the ball is continuously moving up, is its velocity going to be reducing continuously or increasing? So the answer would be reducing, because we all know that because of that gravitational pull, we all know that the velocity of anything which is thrown up keeps on reducing till there is a point where it stops. Okay, so it is this point where it has stopped. Okay, so this first part of the graph, this first part of this first graph is actually resembling our case. But let us look at the second part of the graph. Now second part of the graph is showing me that the velocity after becoming 0, it is increasing again. Okay, so you can see that with time, with increasing time, the velocity is again increasing, and it is increasing in the positive direction again. Whereas we know that whenever a body is thrown up, its speed reduces, and then once it becomes stationary, it starts to fall down. Okay, so its velocity during the downward journey increases, no doubt, but then is it happening in the same direction? No, the earlier direction was upwards, now the direction is downward. So this part of the journey which is shown above the x-axis is wrong. So this is not following our case scenario. Okay, so although this first part was similar to our discussion, but this second part is actually not following what pertains to our problem. So now let's have a look at the second graph. In the second graph, once again, the first part is quite familiar. You can see that the motion started with a particular velocity because the person had thrown the ball with a particular velocity. Velocity keeps reducing and then it becomes zero. And then what should happen? What should happen is that suppose the ball has reached a height and now its velocity is zero momentarily, and then once it starts to move back down again, then its velocity will keep increasing. Okay, but it will increase in the negative direction. Okay, it will increase in the negative direction. So you can see that the velocity is increasing in the negative direction, but still this answer is not going to satisfy our case scenario. What is the reason? Because although we see that during the return journey the velocity is increasing, but do you see which way it is going? It is going towards the left hand side, which means that the time is again reducing. Can time reduce? No. Once the time starts, no matter whether the ball is going up or coming down, time always is supposed to be increasing. So instead of this part turning like this, it should have continued to go along to the right side in this fashion. So which takes us to this particular scenario, which is the fourth scenario, which is actually the case which pertains to our situation. So let us analyze this graph also. Now we started with a particular velocity. The velocity kept on reducing. Why? Because the ball is going against gravity, so it is losing velocity, it is losing energy. So at one point it is going to stop. Now it has stopped here. After that, what happens? The ball turns, its velocity starts increasing again. So you can see that the velocity is increasing. Why is it increasing? Because you have v, positive v in this direction. So let me just draw this arrow to tell you. Velocity is increasing in this fashion, upwards also and downwards also. The only difference is that once your graph crosses this origin and comes below, then that only gives you a velocity value as a negative value, because anything on the y-axis below this origin is going to give you a negative value, and negative velocity means only change of direction. Okay, so did our ball change the direction? Certainly. Once it reaches a fixed point, a height, then it has to come down in the reverse order, in the reverse direction, and that is why it is going below the x-axis. So why should it continue to go like this to the right side? Because time keeps on increasing whether you are moving up or down in a journey. Okay, so this is the correct option according to our case. Now let's come to this case also and analyze this. This will be readily rejected because you can see that although we are starting with a particular velocity here, it is decreasing, all right, but you can see that this side the time is decreasing. So you cannot have time decreasing when the motion is taking place. So that is why this also is going to be rejected. So this option is the correct option. Okay, so now coming to the next question. Now these are all analyzing questions where you actually will not have to solve much, but you will have to have a better understanding of the concept. Now this is a displacement versus time graph. Okay, it's in the form of a curve which is moving like this, and these are all different points during the motion. Okay, the question is at which point or points. Okay, so your answer can be a single point, A, B, C, D, E, or a combination of number of points where the velocity is zero. Okay, so the question is at which point or points is the velocity zero. Remember, they are asking for the velocity to be zero and the graph is given between displacement and time. Okay, so you must have a very clear understanding of how you get velocity from displacement versus time graph. Just like when we were discussing velocity versus time graph and you wanted to find out acceleration, we found that acceleration can be found out by the slope of Vt graph. Okay. Similarly, velocity can be found out from displacement versus time graph if you find out the slope of the graph. Okay. So essentially what that means is that for velocity to exist, for velocity to be finite, or for the body to be in motion, there should be a change in displacement taking place. Okay, between with respect to passing time, you can see that the time is passing along the x-axis. That is why we have time on the x-axis. So the displacement should also change with the time. As long as that is happening, velocity is not zero. So we have to look at any such point on the graph where displacement is not changing with the time. Okay, at that point or at those points the velocity will be automatically be zero, because velocity is nothing but rate of change of displacement. If you go by definition, velocity is rate of change of displacement. So the displacement has to change with respect to time. If it is not changing, then naturally the body is at the same position, so the velocity is zero. Okay, so that is the understanding behind this particular graph. Now let's see, let's consider point A. Now at point A, if you draw any tangent to this curve, okay, let us draw a tangent. Because why are we drawing a tangent? Because we know that from a displacement time graph, if you want to know velocity, you must know the slope of the curve. Okay, so at this point, if you want to draw a tangent, it will look something like this. So let me use a blue color to show you. It will look like this. So which is naturally telling you that with passing time, displacement is also increasing. Okay, so when displacement is changing with time, velocity cannot be zero. Same goes with B. But have a look at C. This is a point where if you draw a tangent, this tangent is going to run parallel to the x-axis. Okay, so if you now want to find out the slope of this curve at this point C, you will see that the slope will come out to be zero, because this is the only point till now. A, B, C, we have covered 3 points. This is the only point where the graph has become sort of parallel to the x-axis. So that essentially means that although time is increasing, but the curve is neither going up nor coming down at this point. Therefore displacement is not changing. And when displacement is not changing, that means the body is not moving. Therefore the velocity is zero. So this is one point where velocity is zero. Now come to D. Certainly if you draw a tangent again, it will be sloping downwards. So that would mean that displacement is changing with time. So even this point has some velocity. The body has some velocity at this point. Now come to this point again, where you can see that after the graph has come down, it has remained stationary somewhere over here, and then it has taken a turn. So if you draw a tangent again at this point E over here, you will again get a line which will run parallel to the x-axis, which would mean that although the time increased for some bit at this point, but did that graph come down or go up at this point? No, it became stagnant here. So therefore the slope of this graph at this point is again going to be zero, which will give us a zero velocity, or the body is not in motion. Okay, so C and E are the only 2 points on this graph where the velocity is zero. Okay.